Okay, what I'd like you to do, we're going to practice a little bit. We're going to be focused here on section 3.2. And 3.2 is all about domain and range. And we talked about this the other day. Remember how we defined a function. A function is a relation from one set to another set. And I drew it, it was up on that PowerPoint that we had. And I'll often draw something that looks like this, where you have like a cloud of numbers, and then those numbers go into a box, which is our function, and then some numbers come out like that, right? And we said that this is x and this is y. This is the input, this is the output. But mathematically, we call this the domain, and we call this the range. And that's what we're going to work on today, is practicing identifying domain and range, limiting domain and range, things like that. What I'd like you to do is open up your GeoGebra grapher. Actually, before we do that, I want to just share really quick from Function Carnival Part 2. Several of you got this correct. The card sorting. I can see, so what it looks like here is an X means that you didn't finish that card sorting correctly, and a check mark means that you did. And you can see about half of you got it and half of you didn't. The card sorting was an exercise in the different ways of talking about a function. I gave you 4 ways of talking about a function on Monday. We said it could be a verbal description, it could be a table or chart of numbers, it could be a graph, or it could be a formula. So this was only using 3 of them. It was using the formula, the verbal description, and the graph, not the chart. So you had to match up the 3. So you might want to go back and look at yours and see if you did this correctly or not. Does it tell you if you got it correct or not? It doesn't, does it? If you want to know, I'll let you know. I can. Scott Williams is just a fake name here, but I can see which ones of you got it right and which ones of you got that one wrong. So I want you to just re-look at that again when you get a chance. You don't have to right now. The other one I wanted to talk about was this one. Only about 4 or 5 of you got this one correct. All right, this is step 14. So if you're on your computer right now and you want to pull up your Graphing Stories Part 2, you can. It says, which of these equations has no solution? Okay, so you just got to look at each one and see if it's going to work. So for the first one, f of c equals 0, they're saying, is there some c value that will make the height of the carrier or the cart or whatever you want to call it, is there some c value that will make that equal to 0? Does it work? Is there a value of c that would satisfy that one? Does our cart ever have a height of 0? No. The lowest it ever gets is, what is that? About 2? So this first one, there would be no solution to that. What about f of 0 equals c? At time 0, can it ever equal some height called c? Sure it can. Because at time 0, it's equal to 8, and 8 could be the c, right? So that one works. How about the f of c equals 12? Is there any time in which it's going to have a height of 12? Yes, it does reach 12, right? So that one works. How about f of 12 equals c? At time 12, will it equal some height? Yes. F of c equals 300. Is there any time that will equal a height of 300? No. It doesn't even get close to 300. The highest it gets is only to there, right? So that one doesn't work. And then finally, f of 300. At time 300, Will it equal some height? Yes. Now we can't see it on our graph, but if we assumed that the Ferris wheel just went forever, eventually we'd get to a time of 300, right? You guys agree with that? And it would be at some height. We don't know what it is, but it would be at some height. Okay, so enough on that. Again, I want you to go through and just check your card sorting and check your other answers and see how you come out. And if you have a question on one step on this that you're like, I just couldn't figure it out or whatever, come flag me down and we'll talk about it. I give you these Desmos activities so that math class doesn't feel like you're just writing in a notebook with a pencil with a bunch of notation. I hope you can feel a little bit of things making more sense when you get to do a little game or a little graph or a little something like that. I'm going to have you do a couple of those today as well. Okay. Everybody got their grapher open? GeoGebra? And let's make it one bigger here. Let's just graph something. Let's graph a line. Down in your input bar, let's graph 2x plus 3. That is a linear function. F of x equals 2x plus 3. So whenever we want to graph a function, we can just type it in, right? What is the domain and what is the range of that function? You should be able to identify it just looking at it. Domain. Anyone? Mackenzie, you look like you want to say something. Any number. Do you guys agree? All real numbers work? This line goes forever to the left, and it goes forever to the right. So if you scan the x-axis with your eyes, does it miss any numbers? No. From negative infinity all the way to infinity. Or another way to say that is all real numbers. That's the domain, the x-axis. Now I'm going to talk about the range, which is the y-axis. What's the range? Is it going to miss any y values? It's going to be all real numbers again, right? Okay. So what happens if I did this? Let's delete that one. And this time, let's say I'm interested in that function, 2x plus 3, but maybe I want to restrict my domain. Maybe I'm only interested where it goes, say, from negative 2 to positive 4, or something like that. Okay? I'm going to show you how to do this on your computer. Down in your input bar, type the word if, I-F, and see what pops up. It's like an if-then statement. If this, then this. The very first one says, if this condition, comma, then. So choose that, the if condition, then. So the condition is going to be the domain that I want. Okay? Let's say I want my domain, this guy right here. Let's say I'm not interested in all real numbers. Let's say I only want to go, I'm just going to make some numbers up. I only want to go from negative 2 to positive 4. See how I wrote that? X is going to be between negative 2 and positive 4. So type that in. Say negative 2, and you can either use the shift of your comma button on your keyboard. That's like a less than sign, right? Or if you wanted to, down here in your, see that little alpha character? You can grab your less than or equal to sign from right there. Actually, you can only do less than or greater than or equal to from here. So if you're going to do it not equal to, just use your shift of your comma. So negative 2 is less than x, which is less than, what did I say, 4? So I've got this. Negative 2 is less than x, which is less than 4, meaning x is going to be in between those two numbers. And then hit your tab button and it goes over to the then on the other side of the comma. What do we want to graph? 2x plus 3. We'll do the same one that we did earlier. And then hit enter. And notice how this is different than what we graphed just a minute ago. I'm going to move my screen so that you can see it. Notice that in the algebra window, we still have 2x plus 3. We had it there a couple minutes ago, right? But now we put in this new condition. We only want the domain to go from -2 to +4. So now look at our graph. Our graph used to be all real numbers domain, all real numbers range. But now notice what it is. The domain, -2 to 4. And then what would the range be? Well, you could use your eyeballs to figure it out. It's going from -1 all the way up to 11. Right? Did everybody get it to work on their graph? So you could do this with anything now. You could double click on it. Let's say, you know what, I don't want to go all the way to 4. I only want to go to 3. So I could change it. And then I changed my domain there too, right? I could do the same thing with any function. Let's say instead of 2x plus 3, maybe I want x squared plus 3. So I'll just change it to x squared. Still going from -2 to 3. It's just a different function, which has a different domain and a different range, right? So we're going to get some practice in the Desmos activity that I'm going to give you, where you can restrict the domain of a function, and you'll see it's kind of like a game that we're going to play. I just wanted to show you how to do it on your GeoGebra in case you ever wanted to graph something like that. Okay, here's what I'd like you to do. Go to course docs and links, the same place where you're getting all of your activities here. Scroll down to 3.2, domain and range. There's 3 of them here. I want to get through the first 2. And then graphing stories, I think we're going to save graphing stories for Friday. Okay, so do you see marble slides and free range functions? I want you to go to marble slides. I guarantee you this is the most fun you're going to have in any of your classes today. Because marble slides are fun. Is that risky for me to say that? Maybe some of your other classes are more fun than this one? Marble slides, okay.
Your problem.
We'll go through a couple together here. I'm just going to load my dashboard here so I can see who's in. So, I see 19 of you are in there. Some of you are already working. If you go to step number 1, you can see the gist of the game here. Whoops. What am I doing? Why isn't that loading for me? There we go. The idea of the game is when you hit launch, the marbles will go, and you're going to try to hit all of the stars. Okay? And what they're going to do is they're going to give you a line, a graph of a line, and what they give you is not going to work. For example, they ask you to fix it on this first one. If I were to launch it right now, notice the marbles are not going to hit the stars. You guys agree? So what they're saying here is you can do several things. You can change any of these numbers to make a different equation, so the blue line is different. Like this one, you'd probably want it to go down, right? So you might want to change the y-intercept so that it goes down. But you could change the slope as well. And then later on, when you get to one that's like, I don't know, number 5, for example, on step 5, notice they have -0.4x plus 6, but then they restrict the domain, just like we did on GeoGebra a second ago. They're saying they're only going to do it when x is less than 4. That's why it stops right here, because on the other side of 4, they don't want to graph it anymore. So you can change the domain as well. And later on, when you get to the more complicated ones, you can actually you can add more lines if you want. Like let's say I wanted a second or a third line. I can just go right to here and I can type in a second y equals. I could go like, I don't know, y equals 2x. And then I put in a second one. See what I did there? So you just got to play with it so that you can get all the stars. And when you get all the stars, go on to the next step. Okay? I don't know if I'm going to give you enough time to finish this whole darn thing, but I'm going to give you some class time to play with it right now. And Oren and I will walk around and monitor your progress. (22) 1, 2, 3, 4, 5, 9, 10. One of you is not in. Is anybody having trouble? Unless I counted wrong. 2, 3, 4, 5, 6, 10. Oh, it is 22. Okay, never mind. Now there's going to be multiple ways that you can figure these out. Like you might get all the stars and your neighbor might get all the stars and you might have done it a different way. And when you really get good, pretend that you only get like one marble slide chance at it. Like see if you can get it on the very first chance instead of trying it, doing it again, trying it, doing it again. That'll make you think a little harder.
This wants to know at what time will he be at 12.
There's 2 times, correct.
2.5 and at 12.5. So I don't know.
Yep, so both of them would be correct.
Okay.
Yep, there's more than one answer.
Okay,
So that would be a discussion point.
I tried to put both and it didn't.
Oh, yeah.
Let me put both.
Yep. Yep. Still missing one? So how are you going to fix that? It was at 8. Now it's at 10. There you got him. Yep. And I bet even like 9.8 would have worked. So there's multiple ways to do it. You could have changed the slope a little bit.
So cold right now.
Yeah?
I broke down.
Would you walk here then?
No, I had a friend. We were trying to change my tire.
Oh. Anybody having any major issues, or is this working out okay? Don't delete the whole line. Did you get that one to work just now? Yeah, all right. So what are we practicing? We're practicing mostly this idea of being able to restrict the domain. You can make the line longer, you can make the line shorter, and then of course you can adjust the y-intercept and the slope. We did some of that earlier, and we're going to do that coming up here too. If you delete the entire line, you just got to retype it back in there. Or maybe if you go back a step and forward a step, does it populate it back in there? I don't know. Okay, did everybody stop? I did that on purpose. In the interest of time, I'm going to let you finish that on your own time. Okay? It's fun, right? Come on. See, some of you thought it was fun. What I want you to do is I'm going to just show you a couple examples out of the textbook, and then you can bring up your GeoGebra grapher as well. Give yourself a new screen. I want to do a little bit of practice on how we can identify the domain and range of a function if it's just given to us as a formula. So this is out of your textbook in section 3.2. The first one says 2x cubed minus x. You might be able to look at that and say, which x values will work and which ones will not work. And then once you graph it, or think about which y values are going to work and which ones aren't. Typically, on these functions, you can start with this thought that whatever function is given to me, I'm just going to assume that the domain is all real numbers. Every number is going to work. Except, what are going to be some scenarios where we know we can't put in a certain number? What do we need to be aware of? And it's not going to exist in this one because this one is going to be all real numbers. But what might we have to look out for in a function? There's certain things we can't do in math. We cannot divide by 0. So if some x value, if some input value is going to make our function have a 0 in the denominator, no good. That x value would not be allowed in the domain, right? What else do we have to watch out for? Can't divide by 0. Can't take the square root of a negative number. We already talked about that. That would give us an imaginary number, right? So those are things to watch out for. So really quick, you can graph 2x cubed minus x if you want to prove it to yourself. Just type it in. 2x cubed, was it minus x? 2x cubed minus x. I hit enter. And I can see on my graph that it's going to go forever to the left and forever to the right, even though we can't quite see it. You could zoom this guy down and you can see it's going to go forever to the right and forever to the left. And then it covers everything up and down. So what's my domain and range? All real numbers, all real numbers. So try the next one. F of x equals 2 divided by x plus 1. Before you even graph it, can you identify any x values that are not going to be in the domain? Is 0 going to be in the domain? Let's try it out. If I punch in f of 0, I'd get 2 divided by 0 plus 1. So it'd be 2 divided by 1, which is 2. So actually that is going to work. Negative 1 is going to be the bad guy, right? Negative 1 would cause a 0 in the denominator. 2 divided by 0 isn't going to work. So now graph it. I'm going to delete this one. You're going to want to do 2 divided by parentheses x plus 1. Hit enter. There's my function in the algebra window. If I look at my graphics screen, and you can zoom out and you can do whatever you want, but it looks like it's coming here and it's getting really, really close to negative 1, and it's coming over here and it's getting really, really close to negative 1, but it's actually never going to get there. Does that make sense? You could even draw in a line if you wanted to at x equals -1. Whoops, screwed that up. X equals -1. So I have that black line, x equals -1. My red graph is never going to touch that black line. It's going to get really darn close to it, right? But it's never going to touch it. You could even prove it to yourself this way. Try to have your computer try to punch in f of -1. Go f parentheses -1. You're going to enter -1 into the function. When you hit enter, it's going to tell you it's infinity because it's rounding. So it thinks like -1 is the same as -0.99999999999. So it's going to say it's at infinity, but it's actually undefined because of the way the rounding works. Try one more out of your textbook here. How about this one? 2 times root x plus 4. 2 times the square root of x plus 4. Before you even graph it, think about which values might not work. Can anybody come up with one value that doesn't work? -5 does not work. Do you guys agree? If I put in -5, I would have 2 times the square root of -5 plus 4, which is -1. I'd have 2 times the square root of -1, which is 2i, which isn't going to graph on our real numbers. So -5 does not work. Does anything else not work? Everything after that, below that. In fact, anything smaller than what is going to cause us a problem? Anything less than... What's the smallest number that we could put in there? Can I put -4 in? Then I would be taking the square root of 0. Is that legal? Can I take the square root of 0? Square root of 0 is 0. So -4 will work. What about -4.000001? That's going to result in a negative underneath the radical. That's not going to work. So everything to the left of -4 is going to be bad, right? So my domain is from -4 to positive infinity. And you can look at the range too. Go ahead and graph it. There's 2 ways to do square root. I'll show you how to do that. Maybe you guys already figured this out. I can go 2 times... now I don't even remember how to do it on here. SQRT? There it is. Thank you. 2 times the square root of, what was it again? X plus 4? There I have it. Notice that nothing to the left of -4 is on the graph. So my domain is from -4 all the way to infinity. What about my range from where to where? The smallest it gets is 0, and the biggest it gets is infinity. Yeah, we can't come up with a negative number. It'd be impossible to come up with a positive, take 2 times that positive and come up with a negative. It's not going to work, right? So your graph and your logic of looking at your equation should match. If you wanted to test -4, I'll try f of -4. Notice it works. 0 works. If I try f of -4.1, undefined. It's not in the domain. The other way to do this, by the way, if you want to do the square root of something, if you understand your properties of exponents, it's the same as doing 2 times x plus 4 to the 1/2 power, 0.5 power. 0.5 power is exactly the same as square root of. You guys might have known that. So that would be the same thing. Okay, I want you to try the other Desmos. So go to free range functions. That's the second one, free range functions. I'm going to unpause your marble slides so you can finish it on your own. But I want you to go to the free range functions one right now. And go ahead and start on it. When you enter an answer on this one, it's going to say submit to teacher. So do that before you go to your next step. And I'm going to monitor what everybody types in here. We're on the second one now, the one called free range functions, the second Desmos. Should have found out that the answer to the first one was yes. It is in the range. So again, as you do these, you can either use your eyeballs and look at the graph. That's one way. Or you can use the formula and just see if you can come up with an actual input value that'll give you that range. And if you can't, it's probably not in the range. So what you probably have figured out by now is that the marble slides activity was all about playing around with the domain, and this one is all about playing around with the range. Hence the name of the activity, free range functions. So on number 4, I can see that right now 4 students have answered yes. Is -2 in the range of x squared? If you're one of those 4 students, you better look again. Remember, is it in the range? Is it in the domain? Yes, it is. Is it in the range? No, it's not. Oh, sorry. I didn't do that correctly. Did it jump everybody to number 10?
Yes.
Sorry. Did it take you back to where you were now? You might have to go back. If you look up at my screen, you can see how everyone voted on step 10. There's no disagreement amongst the class whatsoever. Everybody agreed that 1/4, 0, and pi were all in the range of x squared. So good, they are. They're all in the range, right? Did pi mix anybody up? Did you have to think twice about that one? Pi is just a number, right? 3.1415, blah, blah, blah. It would be in the range. For the ones that you guys entered on step 11, you should answer on step 12, are all the dots and x's in the correct place? It seems to me that they are, right? And x is a red one that's not in the range. The blue one is. Those of you on step 13, any tricky ones? 0 we already talked about. How about 1/6? Yeah, that's in there. How about 7.777777? That one's in there. How about, since nobody's coming up with a tricky one, I'll come up with a tricky one. How about the square root of 2? Is that one in the range? Sure it is. That's a real number, right? How about 2i? Why not? That's an imaginary number, and what the only world we're playing in right now is the real number world. So yeah, 2i would not be in there. Okay, most of you are done with this, but go ahead and finish it if you're not. Finish the marble slides. Finish the carnival part 2 if you hadn't already finished it for today. And you should now be ready to take your 3.1 and your 3.2 quizzes and any practice homework. And when you come back on Friday, we will be looking at 3.3. See you then.